Hello, it's Duncan. Our acceptance test strategy here on Team Gilded Rose has been a bit haphazard. We have some tests that talk directly to our app object, others use HTTP4K in memory to interact with the routes, and yet others fire up a server and use Playwright to pretend to be a user with a web browser. It would be nice if we could write our tests once and then run them in all three ways. Now, we could develop that functionality from scratch, but if you're a regular viewer, it won't surprise you to find out that we're going to refactor our existing tests until we reach this nirvana. I think this is the most advanced refactoring I've presented so far. It involves removing duplication by gradually changing multiple methods until they're all in the same shape. And once they're the same shape, we can use our usual techniques to remove duplication and reveal an abstraction. We start today with a comment on last week's video from Marianne Schubert. They noticed that I made an error in my waiting for HTMX function. Let's just go and have a look at that and see what the issue is. Okay, here it is in page waiting for HTMX, and this unsets a flag that's later set in the JavaScript event listener. And I messed it up in two ways. One, I didn't reset the right variable, so these had both been named data loaded fired at one point. So that should be that. And secondly, this is an equality test, not actually setting a variable, so it should have only had one equal sign. Now, when we mess up like this, I think it's a good thing to consider why we did and how important it is. And the reason why I messed up in this case is that we never invoke waiting for HTMX twice, so we never need the variable to be reset. Does it matter? Well, at the moment we have no tests that fail, but I suppose if in 6 months' time, say, we had an interaction that required waiting for HTMX twice, then it would be a lot harder to debug, because by then we'd have forgotten how this thing worked and we'd have to regain that knowledge. I suppose it's the nature of test infrastructure that unless we're writing a specific library, we only really ever test our test infrastructure with the test that we have. I think I'm going to partly learn the lesson by exercising this code by changing the test, checking that it does work, and then reverting the test because I'm not really going to need that functionality yet. I won't bore you with it in real time. Here it is speeded up. Actually, I say that though, I do have one thing to say, which is that you'll notice the first thing I've done is undo the change in order to establish that it is actually required. Anyway, now on with the music. Well, if you're watching that, you'll see that I dropped into the debugger a few times, which is a sure sign that things weren't going right. And in retrospect, the problem should have been obvious, but it really wasn't. It turns out they need to call install HTMX support here, and the reason is this check reloads the same. Because we've actually reloaded the page, the event listener that's installed in install HTMX support has disappeared in this reload, so we need to do it again here. Oddly, the acceptNext dialog hasn't. But I think that's because it's managed by Playwright and is scoped to the page in some sort of way. If I didn't check reloads the same, then I think I could get rid of that and run. That's true, and had I messed this up with Fred, I think that wouldn't pass. Phew. Okay, let's undo that, check that we're okay again. Good. And now with the knowledge that this is working properly, although we do have issues with page reloads, I think we can revert the delete items acceptance test and commit this with fix resetting HTMX has settled flag. As we've discovered in the process of this, that our test support has a weakness, that we are going to have to call this after things like check reloads the same. I don't know the solution, we're just going to have to keep it in mind if and when our tests get more complicated. I suppose we partly wouldn't have made that error had we had a variable for this name. So I think maybe that's worth doing if we were to make this into a property and we'll call it HTMX. For some reason I can't see the name of it. HTMX settled, let's do with that for now. So let's put that there. Not there though, interestingly. and there and there. Does that mean we messed up the name? I don't think so. So I don't know why it hasn't replaced that other one. Put that in there, and run again. Good, and I think maybe just amend commit. Okay. Now our actual goal for today was to rationalize our acceptance tests. In the case of delete items, for example, we have this delete items acceptance test here that sets up the system in some sort of way and then deletes some items with Playwright and checks that the system is as we expect. But we also have these delete items tests over here that we wrote before, and they set the system up in fact exactly the same way. It's not a coincidence, it's just that I copied the one into the other. And then they exercise delete items, in this case talking directly to the app. There are some special cases when we're talking directly to the app that we're not testing via our acceptance tests. And then we also delete items via HTTP, and we delete items via HTTP with no HTMX. And in these cases we're going through the routes, but we're not actually firing up a browser, we're just making a request, looking at the response and interpreting it. Now, duplication, especially in tests, isn't necessarily a bad thing, but it's often worth pulling on the thread of what would we get if we removed it. Because duplication is normally a sign that there's some sort of abstraction trying to get out, and abstractions are often useful to us in software. The problem is that this duplication isn't the sort of duplication that IntelliJ can look at and say they're the same thing. It's more subtle than that. We can see here that we are clicking on 2 checkboxes and we're sending 2 checkboxes through here. And we can see here that we're checking the status and then checking what's happened on disk, but it's a subtle duplication. In order to remove this subtle sort of duplication, a good trick is to make them look as identical as possible. So that's the process we're going to go through today. And the tests we've got to work with are one here, and let me have a look. There's delete items, delete no items, delete non-existing item, delete via HTTP, and delete via HTTP with no HTMX. So we've got 6 or 7 tests to make it look the same. Okay, so let's see. The first gratuitous difference is this here, using different assertions. This is fixture check stock list has, and this is assert equals something and something else. If over here though we drop this list down, we can see that because we're starting with the same fixture setup and we're deleting the same items, 0 and 2, then the stock list we're checking against is the same one, it's just got 1 left in it. Although we seem to be chopping and changing between the fixture stock list and the price stock list that we came into here, it's all a bit arbitrary. We're just going to have a look at our fixture. Here it is. We start with a price stock list and we derive an unpriced stock list from it here. I think we might reasonably name this original priced stock list to reflect the fact that it doesn't change if we update the stock. We actually have to load the stock in order to do that. That's what's happening down here, this load. And this would also be original stock list. And this unpriced items, that's our persistence here. I think since our change to make unpriced and priced items different types, we could just call this items. I'll run all the tests to check things are okay. And they are. Now we've got this check stock list has. This is very much a convenience function to allow us to use var args in places like this. If we take this middle bit out as a method called check stock list is, that would have to be context of IO to reflect the fact that it is doing some disk stuff or some database stuff. And then what I'd like to do is pull this stock list out as the parameter to it. So if we make that the parameter, then it will replace all the others. And I'm just looking at the spelling here. I think I'm going to fix that one to make it a capital L. So now we have check stock list is. That is effectively what delete items test was doing here. And then we make the check, but we know that check could be fixture dot check stock list is expected. So that can go, and we'll check that everything is okay. It is, and now we've got that shape. Well, we can do the same thing over here. So outside run with Playwright, we can say, here's my expected. And then once the Playwright has done its thing, we can check the stock list. And in fact, we can do that outside our run with Playwright. Let's run all of our tests. Okay, so now let's go and make these other tests the same shape. Here we've got delete no items doesn't save the stock list. What's our expected in that case? Well, it's the fixture's original stock list. So I can say val expected is fixture.original stock list. And then we can take this fixture check stock list and put it in there. Is that true? Yes, good. This is the same thing here. Delete non-existent items doesn't save it, so we expect that. And the check is that. Delete items via HTTP. Well, here we're deleting 1 and 2 again, so we can take the same expected, put it there, and in fact I'm going to do the same thing down here, so I still got it in my buffer, and then this can replace that and that. Run, and we're still good. Okay, so we now have the same shape around knowing what we expect and checking it. They're all doing the same thing. They're setting up a variable and then checking it at the end. That's good. What's next? Well, each test has a set of things that it's going to delete. So I think we should say in here, the set of things we're going to delete is 0 and 2 here. So let's write that out. It's val to delete is set of, and in this case we can go to the fixture and say fixture original stock list, and we're going to take 0 and 2. Now we want to convert that into an operation. So instead of specifying it here, we're going to say val IDs is my to delete map it.id and then to set. And that should be the same thing as this if we've got it right, and if it is, I can just say IDs in there. Have I got it right? Well, apparently so. Let's apply that same trick over here on the left-hand side to our browser-based tests. So here we can say, what do we want to delete? Well, it's that same thing. How are we going to delete it? Well, we need to check the checkboxes. So here we're going to say, instead of this checkbox 4, we're going to call this checkbox 4 in a loop. So we're going to say to delete for each, and then we're going to say checkbox for it, where it is an item, and we want to click that. That's not working for some reason. Let's have a look. Checkbox 4 was taking a priced item. I don't really care, but let's just make that item. So now, this test and this one are in the same shape, where this bit in the middle here is take some IDs, map them to set, and call app delete items with IDs. And in the middle here, we have this code, which is doing the equivalent thing with the browser. What about the next test on the way down? Well, delete no items doesn't save stock list. Delete no items is saying to delete is an empty set. And we're going to have to tell it of item. And now instead of having empty set here, we're going to take this code, which uses to delete, and use that to generate our empty set for us. Why? Well, we're trying to make everything look the same shape. So this is the shape. Does that run okay? It does, good. Now we'll go down and delete non-existent item doesn't save stock list. We want that to be the same shape. I suppose if we take to delete from here and we just create an item that we don't have. So here we can say this is an item. We're going to have to give it some ID, which is our no such. This is not in stock, just to give us some sort of clue. We don't need to give it a sell by date, and we give it a quality of 0, doesn't matter. So it will just have that, which doesn't exist. Now we can take this as our action and paste it in there. Run. And we're good. Is this a bit of a faff? Yes. Would I always use such baby steps? No, but I think it's good to practice. Okay, delete items via HTTP. Going to do the same thing. What is it we want to delete in this case? Well, it's the one we happen to have over here. Let's take that. So we're going to say to delete. Now, how do we make a request from our to delete? Let's do it the old-fashioned way before we get to Flash. We'll pull this out as our base request. So this is our request, and we can form the request we want if we took that request and then applied form once for each of our items. So what we'll do is we'll make this a var, and then we'll say to delete for each, and then we will say that our request is now the request with a form parameter like that. Where this, though, is not that one specific thing, it is each.id, toString. If we did that, then we could just call app roots on the request and then check the response was right, and then check the stock list on disk is as we expect. Is that all true? Well, yes, it is. And now instead of this variable here, we can loop over our eaches with a fold. So the equivalent of this code is val r for now is to delete fold, and fold takes an accumulator and an item, but it also takes an initial state, and that initial state is going to be this request here, the one that we want to add everything to. So I'm going to put that in there, the bit icky, we'll come back to it. And now this accumulator is going to start off as this request, and we're going to say ack.form, in fact the same thing as we did here, where that is item. If that's true, then we could just make that R. We'll fix everything in a minute. Delete that. Wrong R, that's that R, and this is response. Sorry about that, run that. Seem to have one too many things there. But other than that, the logic is good. So I think we can pull this out as a variable of base request. This is our request. But I messed that up because the base request wants to include the header. Take that out of there, put it into there, and run. Good. And now we can do the same thing here, just with a slightly different base request. So we're going to say to delete is those items. My base request, well, in fact, let's copy all three of those lines. So my base request is the delete items, but without the HTMX header. I want to fold the form in, though, in the same way. If I've done that, then I don't need to do those. So this can go away. And that is that. Good. Okay, then. So now these are all in the same shape. They have a to delete. They have an expected. They have an action that takes the to delete and uses it to affect the system, and they have a check at the end. And I suppose given that there's no interaction between this expected and the code in here, we can inline that there. And we can inline that there. And that one, not entirely clear to me that I needed to have pulled that out in the first place. Run all the tests. Good. Now then, we have a number of tests, and we have a number of ways to run those tests. So in the case of delete items here, this test and this test are the same one. They just differ in how to run the test. In this case, we run it with Playwright this way, and on the right, we run it by invoking a method directly on our app object. That same test is also here via HTTP, where we're creating a request with the right parameters on it, and then we are submitting it to the app's routes. So how do we make those look the same? Well, I think the answer is a function. So let's start on the right-hand side. If I take this and make a method out of it, that is going to be delete directly. Well, there are two other places we use that, so let's fix them all. We use it in the two cases where we don't actually delete anything because either we have an empty set or a set of something that isn't there. So replace those. Let's do the same thing with delete items via HTTP. So we're going to take all that code in the middle and we're going to make a method out of it, which is going to be delete with HTTP. And we can do the same thing with no HTMX. So this is delete with HTTP, no HTMX. And now I'm going to pull those three things together. This delete directly, my delete with HTTP, and my delete with HTTP, no HTMX. Now, these appear to have the same signature. They all take to delete as a set of items. That's good. But actually they depend on different things. This depends on app and this depends on app routes. But I suppose we could make them all just depend on app by introducing a parameter here, which is our app. And then, because that's in a rubbish place, we'll fix it up to there. And we'll just call that app. If we've done that, then this now doesn't depend on our test at all. It's effectively, it's static. We could take it out of here and move it into the top level. This failure here is because delete items with ID requires our IO context. But that's fine, we can make this like that. Okay, so we'll do the same thing here. We'll introduce app as a parameter. We'll then fix up our signature. And we'll take this and we will pull it out of our function. And note this doesn't require context of IO because it's talking over HTTP, and so the IO is hidden inside our app, inside these app routes. One more to do over this side. So we're going to take the app, make a parameter, picks up our signature, and take this out. And now we're going to do the same on the left-hand side. So we're going to take this, make a method out of it. This is delete with Playwright. This is my app. And I am going to do that, and cut this out of the test. And now show running, that's a bit of a problem. I think we'll just pull that out into the top level of this whole file in order to get things compiling. Do all of our tests pass? They do. Good. So what we have now is one test, this one that is actually deleting two items. That is implemented 3 times. It's implemented with Playwright here. It's implemented with delete items here, and with HTTP here, and HTTP no HTMX here. And you can see the shape, they do a thing, and they're all identical apart from the thing they call in the middle. And we have some other tests that we are only using delete directly with, but we might reasonably want to do those via HTTP or with Playwright. So we want to extract a contract from our tests. And we can do that as an interface or a class. I don't know which is sensible. Let's try an interface, see how we get on. Actually thinking about it, I suppose we want our contract to have these fields, this state here as part of it. This is our setup. So I think we're going to say extract superclass. And we'll make that a separate place, and this is delete items acceptance contract. What does it want to have? Well, it wants to have effectively our given, as set up here. And now there are 3 actual tests. There are these 3, and the 2 down the bottom are a duplicate of delete items, really. So let's refactor that. Now it's complaining about delete directly. I think that's a fair cop, but I think we're just going to continue and see how we go. Going to add that. Let's go and have a look at that file. It's here, and we'll move it over here while we fix it. For some reason, IntelliJ has decided not to automatically import a bunch of things. Fix these up ourselves, I suppose. Don't know where T went. Don't appear to be able to import it. We can import that. These others, I think we'll have a look at where they were imported from here. What on earth has happened with T? That's really strange, IntelliJ. And local date, you've lost local date parse. It's a bit frustrating when refactorings go backwards, so we'll do these by hand. This one is local date parse. It seems to have made up methods that don't exist. I don't know. This is price. Okay. In-memory items. Okay. Okay, and this was the thing we knew it didn't know how to do, which is delete directly. And then check stock list is no, but we don't know about stock list. What's its problem with that? It hasn't moved the context either. So this needs to be context of IO. This will serve us right for living on the bleeding edge. And in fact, we don't want that there, do we? So we're going to have to move this context and IO resolver over here as well. Make this not an open but an abstract class. And it almost compiles, except that it doesn't know how to delete directly. But as a contract, we don't want it to actually delete directly. We want it to delete in the way that is specified by its actual implementation. So I think I'm going to rename all of these to be do delete. And now that doesn't exist, but I could make it exist if it was a function passed by the subclasses. So this would be val do delete, and in order to match the signature here, it would be a function that takes an app and a set of item and return unit. It's just an action. So now usefully that compiles, and we extracted things from the delete items test here. So in this case, I think we will delete with HTTP. So our parameter here, which is do delete, is delete with HTTP, and it's a reference to the function. Okay, I think we may nearly be there. So we've now got this delete items, which is doing do delete, and this delete items via HTTP. Well, that would be doing the same thing as this delete items. So maybe, just maybe, we can delete that and that, and everything will run. Well, that's quite nice. So this is now going to be, I think, delete items HTTP tests. But note that we've run a number of tests here, the empty set ones and the items that aren't in stock ones, against HTTP when we hadn't before. Those ones were previously run with delete directly. So in fact, I think we could say we now have another test that is delete items directly tests, and this is going to be run with delete directly. There's an issue here now that this requires context of IO. I think now that we've got so many routes into the app, we're going to relax that by removing the context IO from here and instead doing run IO on this block. And you'll probably see where this is going. We could also have delete items HTTP tests, but it would be HTTP with no HTMX. This would be delete with HTTP no HTMX. And if we run all of our tests, and look at them, you will see that we now have 1, 2, 3 tests there. We have 1, 2, 3 tests there. and almost certainly somewhere else with the HTTP ones, 3 tests there. That only leaves our previous acceptance tests. Go and look at those, and now we know the shape. So we can say that this, move it over there, is a delete items acceptance contract. In order to be one of those, we need to tell it how to delete. So do delete is, what did we call it? We call it delete with Playwright, but don't actually call it reference it. That should allow us to get rid of all of this, leaving just that. Is that true? Well, let's put show running is true here and run this test. One down. And now we've hung. Well, after a timeout, that finished with delete non-existent item doesn't save stock list. Why was that? Well, we were waiting for a checkbox with no such to be on the page, and that can't happen because it wasn't in the stock list. So we probably don't want to run that test with the browser. That's okay though. All we have to do is say that in the case of delete items acceptance tests, and I suppose this is going to be delete items browser tests, we want to override the function which was, look in the contract, delete non-existent item doesn't save stock list. So we'll remember that. I wonder if it would delete. No, so we're going to paste that into there. This seems to be saying it's final and cannot be overwritten. Well, that's quite interesting. I suppose it allows us to say which items in our acceptance contract will allow to differ in any way. In this case, we can say, let's make it open. And then this, we can't even try this in the browser. Does it run? There's one. There's two. And there we go. Turn that off and run all of our tests. Splendid. Final little bit of tidying. I still think we should be able to get rid of that and import it. But no, very strange that, isn't it? Maybe we can just go and get the IO from here, put it into there, and remove that. Well, that seems happy. That should say browser. This is now delete items browser tests, but is in a different file. Can we fix that here? Rename file to delete items browser tests. Good. And over here, I think we should probably pull this one out into its own file. So this will be delete items directly tests, and that will be that one and that one. Add. And then this one is delete item HTTP tests, and there are two of them. There's with and without HTMX, which seems good to me. There's some slightly irritating duplication here that I think we could get rid of if we pulled this into a method, which is with delete form. There's the duplication we wanted to remove, and then we can move the base request as the receiver. Pull that down in order that we can see the difference between these and run everything. Good. One last little tidy because I can't help myself. I think we should inline that like that and that like that. Now, you may notice that the tests are now taking quite a bit of time to run, and that's because the browser tests are slow. We might want to pull them out to run them in a different Gradle target. In fact, they're really demonstrating right now that they are exceedingly slow, or maybe they're just flaky. Goodness me, they failed. Why is that? Let's have a look. And there we are, delete items has failed after 30 seconds. Why? Looking for a checkbox that I think we know is there, or at least really should have been. Try running everything again. And we're good. So it turns out that even using Playwright, we have got a slightly flaky browser-based test there. Is there a risk condition in our code? I don't know. We'll have to keep an eye open for that. But for now, I think let's check in. Goodness me, quite a bit. I think this is going to be extract, delete items, acceptance contract, and run the same tests multiple ways. And we are done. Reviewing what we've done then, we saw that we had duplication in our acceptance tests, and that was caused first of all by us just copying and pasting from one to the other. But in some ways that was a good thing because it meant that they all kind of had the same shape. They're all a bit different though, so we refactored until they all looked the same, bar the bit in the middle, and then extracted a function, these delete directly, delete with HTTP, etc., to express the way that each actually ran the operation that we were going to test. And then we extracted this delete items acceptance contract, parameterizing it with the way that the individual subclasses would delete an item. Now we could have actually used an abstract method for that, that would have been fine. But by having these as separate functions, it means that we might be able to use them in other tests. So if we had a workflow test that added and deleted items, for example, then we could use these functions as part of that. That's harder to do if they're a method. What's next then? Well, I suppose it would make sense to do the same thing for our add items test. I won't put you through that now, but I think maybe I'll release a bonus episode with that run fast forward, with maybe some more calming music this time in the middle of the week. If you'd like to see that, then please subscribe to the channel. Don't forget to hit the like button so other people can find this content, and then go out and buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.